Hello, I'm back. What we have here today is a Doppler effect problem. This one is actually an underwater Doppler effect problem, but it works the same way as a Doppler problem when you have sound waves traveling through air. So this one features two submarines, a Russian submarine which is pursuing an American submarine. The American submarine is moving at 70 kilometers per hour while the Russian sub is moving at 50 kilometers per hour. The American sub emits a 1,000 hertz pulse of sound, and the speed of sound in water is 5,470 kilometers per hour. And the first thing we want to know is what is the frequency detected by the Russian sub? Okay, so we'll start out with that. All right. Let's see. Our Doppler formula goes something like this. F observed is equal to F of the source times V plus or minus VO divided by V minus or plus VS. Okay, and we'll get to what those signs mean in just a bit here. All right, so in this case, let's see, the American sub is emitting a sound, and the Russian sub, which is then being detected by the Russian sub. Okay, and so the American sub is going to be our source. The Russian sub is going to be the observer. Okay, just so we can keep this straight, I'll just sketch this out real fast here. So there's the Russian sub. There's the American sub, and it says the Russian sub is pursuing the American sub. So we'll say that they're moving like that. Okay, so the frequency of our source, that is our 1,000 hertz pulse of sound that the American sub is sending out. Okay. V is the speed of sound, which is 5,470. Let's see, the observer here, okay, that's going to be the Russian sub. Okay, in other words, the frequency detected by the Russian sub. That's our observer. The observer, remember how this works. If the observer is moving towards the source, we take the top sign. If the observer is moving away from the source, we take the bottom sign. Here, the observer, the Russian sub, is moving towards the source, the American sub. And so that's going to be the top sign, which is plus 50. Okay? And then we divide this by V, which is the speed of sound again, 5,470. The source is the American sub, okay? And again, we take the top sign if the source is moving towards the observer, the bottom sign if the source is moving away from the observer. Here the source is moving away from the observer, and so we want the bottom sign, which is also plus. And this works out to 996.4 hertz. Okay? They're both moving in the same direction at almost the same speed, and so we actually don't get too much of a change in the frequency at all. Okay. B. The signal bounces off the Russian sub and is reflected back towards the American sub, and we want to know the frequency of the return pulse that's observed by the American sub. So what the sound is doing here is it's traveling from the American sub to the Russian sub and then back to the American sub again. Okay, so the sound is making actually two journeys here, and we have to take into account the Doppler effect for both of them. In other words, we've got to do two Doppler effects here. Okay. Now, luckily, we've already done the first one, so we don't have to do this again. But the point is that for the return sound, the echo, the sound traveling from the Russian sub back to the American sub, this is going to be the frequency of our source. Okay. So we start out again. FO equals FS, V plus or minus VO over V minus or plus VS. This is 996.4 hertz. Now for the return pulse, our observer is the American sub, and so that's doing 70 kilometers per hour. and it's moving away from the Russian sub, so we take the bottom sign, which is, in this case, the minus sign. Okay, and in the denominator, the source of our echo, okay, so the sound that's returning from the Russian sub to the American sub, the source for that then is the Russian sub. It's moving at 50, and the Russian sub is moving towards the American sub, and so I take the bottom sign here in the denominator, and that's also going to be minus, and that leaves me with about 992.7 hertz. Okay, and so that is the final frequency detected by the American sub for the return pulse.